All right, let's look at homework 2.2, problem number 9. All right, so we have the graph of a position function, velocity function, acceleration function, and a jerk function, and we have to identify those guys. All right, so let's do that. All right, so let's start with something. Let's see. I'm gonna start from something. Let's see. How about B? All right. Let's look at B. All right. So B has a horizontal tangent line. That means the derivative 0, right? Like right here. So if you look at this point right here, right? The derivative is 0. So derivative of B is 0 at this point. So derivative of B equal to 0, right? So look for the graph who actually hits the x-axis. So that means that it becomes 0. You can see that here. This curve A actually becomes 0. Actually, that's the only one that becomes 0. So it seems like if you take the derivative of B, you're gonna have A, right? Then here, looks like here B becomes 0 when C has a horizontal tangent line. So let's see, if you look at let's see this point, and if you look carefully, you can see that right around this point, it's kind of hard to see, the tangent line becomes 0. So if you take the derivative of C, and it's going to be 0 because you have a horizontal tangent line whose slope is 0, and who becomes 0 at that point looks like a B becomes 0, which means that the B is the derivative of C, right? So we have B is so if you take the derivative of C, you're going to get B. All right. Then what else? So if you look at the D, looks like D is always positive, right? So if you look at the, let's see, so we have to place something. Maybe I should look at it this way. So C, derivative of C is B, derivative of C. So let's say you take the derivative with respect to time, say, right? Then you're going to get B, right? Then if you take the derivative of B, we found that to get A, right? So we have that. Then we have to think about, so if you look at the D, right? So D is, let's see, if you look at the slope of D, and slope of D seems like always positive here, right? So if you want the derivative function of D, so if you want to find the derivative of D, and you can see that the derivative has to be, so a derivative is going to be positive. So we're looking for a function who's always above the t-axis. Then you can see that the A goes below, C goes below, B goes below, and C is the only one stays above. So it seems like C is the derivative of D. Right? Now we have this D. Oops. Maybe I should use D. If you take the derivative of D, you seem like we're getting a C, right? So we can see that, okay, so it makes sense to start from D is the position function, and the C is the velocity function, and the B is the acceleration function, and the A is the jerk function, right? So let's type it in. All right, so what we had was D, C, B, and A. All right, so let's check the answer. All right, it came back and looks like we got all these guys correctly. So key is look at the a place where you have a horizontal tangent line. Then look for a function who becomes 0, which means that it hits the t-axis, and that's most likely the derivative of the function. All right, that's it. I hope that this was clear.